Today I'm taking a look at the Vatrer 100 amp hour 48 volt lithium iron phosphate server rack battery. This is rated at 5,120 watt hours. What I want to do is take a basic overview of the battery and then hook this up to a hybrid charge controller inverter and basically run it through some tests. I want to charge it up with solar and then do a discharge test to see how this performs. Let's go ahead and connect the inverter charge controller up to the battery and then turn the solar on to watch this charge up to 100%. Connecting to the battery is fairly simple. I'm going to remove the plastic covers from across the terminals here, and then I'm going to use a screwdriver to just loosen up these, and I'm going to be able to remove them all the way. Now, I recommend that whenever you actually install this battery, you use a socket set so you can get these snug down nice and tight. The battery is off, the inverter is off, and now it's time to get these connected. So I'm going to get my negative and place it right here. And I want to make sure there's nothing between the cable and the battery itself. No washers, no clips or anything, because you want that connection to be as good as possible. So got that one. Move over here to the positive. Now, because the battery is off and the inverter is off, there should not be any issues with a spark. So I should be able just to connect this straight away and get that done here. Now that I've made my battery connections, I'm going to turn the breaker on down here to turn the battery on, and I will see if the display comes on. If not, I can press the power right there. Still at 53%, but we are in standby mode. So now that I have the battery turned on, I'm going to go into my inverter before I have any solar installed. Go ahead and turn this on. The battery is now charging at 1.5 or 1.6 kilowatts. I had some issues with my settings and I finally got those fixed, but you can see right here I have limited the battery to 30 amps for the current. It's at 54% and is moving along with this charge. So I will let this sit for a while. It may take a day or two, but we will get this battery fully charged. The battery has now reached 100% on the charge from solar. It's now time to do our discharge test. I'm going to remove the incoming solar from the inverter, and that way we will be able to do a full test on the capacity of the battery without solar coming in. Here is the setup for the discharge test on this battery. I've got a small heater that I like to use for my load. I've got the battery hooked up to the inverter up here, and this will be able to output to that heater. And then I've got something known as a kilowatt meter down here, and that will keep track of our watts and time for us. So the battery is on and is currently resting at 100%. I'm gonna go ahead and turn the inverter on here. I just heard the inverter kick on. We've got 119.7 volts, which is good. Let's see, 60 hertz, that's what we want. All right, everything is being reset here on this display. Let's turn this all the way up to the highest setting, which is number 3. Go ahead and press start here, and let's see what we have. We've got 1,422 watts coming out of this battery, and that is a current of 29.8 or 30. So 30 is the maximum there on our discharge. So we should be good. So let's consider this real quick. If our battery has a total watt hours of 5120 divided by 1422 watts, we should see approximately 4 hours on this heater runtime. So that is our goal. Now, of course, there's going to be some limitations because the inverter will be pulling power as well, and we don't always want to pull this down to exactly 0. So we'll see how well this test runs here over the next 4 hours. I actually just saw something here on the display of the battery. It says time until discharged, or let's see, time to empty is 3 hours and 19 minutes. So yes, I was off by about 40 minutes, but honestly, a lot of that is going to be because of the inverter's draw as well. Let's take a look at where we are so far. 2.5 hours have passed. The battery is now at 25%. It says it has 48 minutes left, and we have consumed 3.64 kilowatt hours. All right, so and the battery is currently at a 51.08 volts, so we're still good on that. Looking forward to seeing how well this gets down to our target value. Well, how we doing here? We're at 3 hours. We have used 4.27 kilowatt hours through the battery, and then we've got 22 minutes left at 12%, and voltage is still doing good, 11% now. So the inverter itself is going to be using a little bit of power just to be on, and that's where some of that extra is going to go. But so far we are exactly on time for what the battery was indicating that it was going to run. I had set up my inverter to have a low voltage alarm, and that has just been triggered. We've got 4.43 kilowatt hours. The battery has reached 49.67 volts with 8% left, 15 minutes on the battery. So it is good to see that this 48 volt battery is getting this close to the end. Now, as far as time goes, let me grab the phone here. 3 hours and 8 minutes. So it would seem as though with the inverter consuming the amount of power that it does, we've still got half a kilowatt to go on this. So it won't quite reach that with the remaining 8%. And let's see, 14 minutes. I'm actually gonna go ahead and call this. When I turn the load off, we should see that voltage jump back up some here on the battery. I got 50.3, 50.4, and yeah, so the inverter has realized that the voltage has gone back up some. So with 8% left and what was it, 14 or so minutes, I think we probably would have reached closer to about 4.6 here on the power output. So, all right, I am satisfied enough with that. The time came out to be just right, and I feel like it is working as it should. The Vatrer server rack battery is performing as advertised. It's played nicely with my inverter charger up here. The discharge seemed to be just fine. Very consistent and steady on its output. This battery is going for a little less than $1,000. One of the reasons that it's able to sell for that price point is that it doesn't have that advanced BMS for talking with your inverter. So it is just a straight battery that's going to work off of state of charge and voltage and all of that, instead of talking with the inverter to control all of those settings. So you can find a link to this battery in the description down below. I'm Seth with the DIY Volts channel, and I will see you in the next video.